So tomorrow we have our last unit test coming up, and this has been kind of a large unit. We've kind of mixed together two topics here. Geometry and measurement along with the statistics. So since we've just covered statistics, let's go back and do as much of the geometry and measurement stuff as we can first. And if there's time, we'll come back and take just a quick look at the statistics part. So anyway, one of the things we're going to have to do is measurement conversions. Things like converting 72 inches into feet. How are we going to do that? Well, we had a formal process of doing it. You make the 72 inches into a fraction by just putting it over 1. Then we're going to multiply by a conversion factor. And in the conversion factor, since inches are on top, we're going to put inches on bottom here so that they'll cancel out. They'll cross-cancel in our fractions.
Let's see, 12 feet, no, 1 foot, 12 inches.
1 foot equals 12 inches. Very good. So that fills in our conversion factor. And now we'll multiply. The inches, as we said, cross-cancel out. 72 times 1 foot is 72 feet. 1 times 12 is 12. And we divide that out. 72 divided by 12 is 6 feet. So 72 inches is 6 feet. Yes, sir?
Could you just do it the easy way since you see 2 ones, just 72 divided by 12?
Yes, you could. You just say, hey, we're going to ignore these ones, and this is on top, this is on bottom, we'll just divide it. Yes. That does work. I'm just kind of doing it out formally, just to make sure everybody can follow. Or you might have something like 112 ounces. Want to convert it into pounds. So again, 112 ounces over 1. What's going to go in our conversion factor? Well, what's going to have to go on bottom? Ounces, right? So they'll cancel out. So what'll go on top? Pounds, because that's what we're changing to. And our relationship between pounds and ounces? 1 pound is 16 ounces. So the ounces cancel out. And we can multiply straight across. 112 times 1 pound is 112 pounds. 1 times 16 is 16. 112 divided by 16 is 7 pounds. Yep. Okay. Next, we might go from standard to metric or metric to standard. We might have like 16 liters going into gallons. What's that? This might be on the final, yes. So what would go over here? What goes in our conversion factor? Well, liters on bottom, gallons on top. What's the relationship between gallons and liters? There's 2 of them. You could have 1 liter is 0.28 or something gallons, or you have 1 gallon is 1 gallon is 3.785 liters. Good. So the liters cross cancel. 16 times 1 gallon is 16 gallons. 1 times 3.785 is 3.785. So we have to do 16 divided by 3.75. What's that? Perfect. 4.23 gallons. Questions so far? Okay.
Pretty simple. Are you going to give us all the conversion?
No. I won't give you a chart, but you can use your textbooks. So they're all in there.
And notes.
And your notes, yes. You might have 13 kilograms going into pounds. Well, 13 over 1 Kilograms on bottom, pounds on top. 1 kilogram is actually 2.2 pounds.
Oh,
Kilograms cross out. 13 times 2.2 is 28.6 pounds over 1, so it's just 28.6 pounds. What if we want to change 286 inches into meters? I would change 286 inches first into centimeters. Put inches on bottom, centimeters on top. 1 inch is 2.54 centimeters. Inches cancel out. It's all ones on bottom, so all I'm doing here is multiplying 286 times 2.54. 726.44 centimeters. You want it in meters? How do we get from centimeters to meters? Remember, within the metric system, we've got the little chart. We're just moving right or left, right? So meters, decimeters, centimeters. To get from centimeters to meters is 2 spots to the left. So the decimal point goes 2 spots to the left. 7.2644 meters. Or 7.26, however you want it rounded off. On the test, if it doesn't specify rounding, 2 decimal places is usually what I shoot for. A little bit different note.
Can you go back up to, so 13, wait,
13 kilograms right there?
yeah, oh,
Oh.
that's.
Yep. Better? Okay, a little bit different note. What's different on this one? Yeah, it's inches squared and feet squared. So I have my 576 inches squared over 1 to make it a fraction. Inches squared on bottom, feet squared on top. Is it 1 and 12 again? Say no.
no.
1 square foot is how many square inches? 12 by 12 or 144. 12 times 12 is what we have to have for that.
Wait. So, okay. 1 inch squared is equal. Oh no.
1 square foot. 1 foot squared equals 144 square inches. Because it's 12 inches by 12 inches. So 12 times 12 is 144.
Okay. I think I got it.
Good. So now, square inches cancel out. 576 square feet over 144, that divides out to be 4 square feet, or feet squared.
You know, I love when you do that. I'm just looking at it, 576. It doesn't look like it should be able to divide by 144.
But it does, yeah. How about this? 3 cubic yards into cubic feet. Obviously, cubic yards are going to go on bottom and cubic feet on top. But how many? The yards are bigger, so it's going to be 1 cubic yard is how many cubic feet? Well, how many feet are in a yard? 3, right? So a cubic yard is 3 by 3 by 3, which is multiplying them, yep. 27. 1 cubic yard is 27 cubic feet.
We already go over this, but in theory it could go beyond 3.
Yeah, the whole fourth dimension. But when we're doing measurements, there's really no practical. So put our 27 in there. Cubic yards cancel. 3 times 27 is 81 cubic feet. What do you think? Can we handle the measurement conversions? Okay. Find the complement of 52 degrees. How would we do that? Complement means I compliment you when you are right. So right angle is how many degrees? 90. So complement means they add up to 90. So it has to be 90 minus 52, which is 38 degrees. Correct? What if I ask you to find the supplement? 26 degrees. What do? Subtract from 180 minus 26, which will be 154 degrees.
Okay.
If I tell you that this angle here is 31 degrees, and I ask you what this angle here is, can you tell me? Well, that angle would be the same as this angle, same as this angle, and the same as that angle. Not the 31, but that whole piece. So this piece here, I'm going to put it in red so I can refer to it as the red angle here. How big does that red angle have to be? Has to be at least 31. 31 plus 90, because that's a right angle. Or 121 degrees. So that angle there has to be at least 121 degrees.
You know, I usually am not right with this stuff because every time I think I have names done, it turns out to be wrong.
Yeah? That's making a little more sense? Good. If I asked you to find side x in this triangle, what would we do?
Well, if X is
Add 9 and 40.
Got the right idea. There's one little piece yet.
isn't it A squared plus B squared?
Yep. So it's going to be 9 squared plus 40 squared equals c squared.
Oh,
So 9 squared is 81. 40 squared, 1600.
and X is
Now we add them, 1681. Now that c squared, however, we got to square root it. Square root of 1681 is 81. Or not 81, sorry, 41. I don't know where the 8 came from. So that means x here is 41.
So here's a bit of breakthrough for you.
Yeah?
Two things. When you told us to find X, X is right there.
Yeah.
And then Santa Claus multiplied by I.
Santa Claus?
Multiplied by I.
Technically, Santa Claus multiplied by I would be the anti-Santa Claus. It'd be a negative Santa Claus because two imaginary numbers multiplied together is a negative number. Hey, nice try, though. That shows some pretty good thinking that you'd come up with that, though.
So close.
So let's find the value of x here. Now, when this one's set up, excuse me, this one's going to be x squared is going to, a is going to be x, and b is going to be 14, and c is 50. So it's going to be x squared plus 14 squared equals 50 squared. Well, the x squared stays the same. What's 14 squared? $196, right? 50 squared, of course, is 2,500. Then what do? Well, we got to get x squared by itself, so we're going to have to subtract 196. So x squared equals 2,304, which means next we need to square root, giving us that x is 48.
Isn't it redundant to say 48 to the first power?
Well, that's 48 feet. That's not a 1, that's a foot mark.
Oh. Okay.
Good catch, though. I probably shouldn't have put it in there since I didn't have feet on any of my other numbers. You're right. So any question on the Pythagorean theorem? Well, you're finding the area of certain shapes. Tetradecagon. It sounds like a dinosaur name or something, doesn't it?
Yeah, it does.
To find area, we need two dimensions that are, remember the key word here? Two dimensions that are perpendicular. In other words, two dimensions that form a right angle. This parallelogram, we have the sides of 20 and 18, but they do not form a right angle. It's not a rectangle, it's a parallelogram. So what we need to find is this length right here. The height, you got it, because that'll form a right angle with the 18. So this area here is going to be 18 times whatever that dimension is.
So 18 times 10 equals
Whatever our area is, we're going to try to find. So we need to find this height here. This is a right triangle. We have two sides. So we've got 12 squared plus h squared equals 20 squared. If you work that all out, which I'm going to let you guys work that all out on your own, should come up with h equals 16.
so how do you get so 12 squared and then 20 squared to get that?
Yep.
But then how do you figure out 8?
Okay, so 12 squared is 144, right? Plus h squared. 20 squared is 400. So we can't do anything with h yet because it's just a variable, right?
Right.
So we got to get it by itself. We're going to subtract 144. So h squared equals 256. Then you square root it. So h is 16.
Basically, it's a workable equation.
You're solving an equation. You're not actually calculating. You're solving it. Yeah. Yep. Yeah, it can be. So now that we know that 16, our area is 18 times 16, otherwise known as is it 288? Yep. And the units on that should be inches squared because it's area. We did inches times inches, it should be inches squared.
Okay, so question, what if you have, problem with one side being inches, for example, 20 inches times, what if 18 over there was feet?
You'd have to convert one to the other so you had the same units. Otherwise, it wouldn't work. That's a good question, though. They do have, when you're finding area, both measurements have to be the same units. Down or up? There? Okay. Since I have this problem drawn up here, oops, you have a question, Billy.
No, I got it.
Okay. How about the perimeter of this? How would you find this perimeter? Perimeter is just adding up the sides. So this is 18, right? This one's 20. How long is this one?
18,
18, and this one is
20.
20. So the perimeter is just going to be 76.
Okay, that didn't work that out.
You missed the other 20.
Huh?
You missed the 120 or the 118 actually. 18 plus 20 plus 18 plus 20.
Usually I use a number like that that's so close to 10.
Yeah,
I add 2 onto the 18 stuff and it was 20, 20, 20, 20.
so it'd be 80.
Then I just subtract 4.
Yep, that's a good idea. For something like this, to find the area, the 20 only goes to right there, by the way. To find the area of this, it's two pieces. We have a rectangle here. I'll call that piece 1. That area is just going to be the 20 feet times the 12 feet, or 240 square feet.
Plus whatever the area of that other.
So the second piece is a half circle. What would be the area of a full circle? It'd be pi times radius squared. What's the radius going to be here?
Half of 12.
Yeah, 12 goes all the way across it. 12 would be the diameter, so 6 feet would be the radius. So pi times 6 squared, but since it's only half a circle, we're going to have to divide it by 2. So I'm just going to use 3.14 for pi. If you use the pi button, that's fine too. Times 6 squared, and then divided by 2.
Okay,
Oops, that didn't work out. 3.14 times 6 squared, then divided by 2. 56.52.
question, where you penalize us if you use 3.14 instead of
No,
5.
I will not penalize you whether you use the pi key or 3.14. Either one will be acceptable. My answer key is made out with both numbers.
My math class basically uses 3.14.
Well, sometimes it tells you to use 3.14. So it adds up to 296 square feet is total area. Questions? Did you have something to say, Cody? Or? A quiz? I think there was supposed to be a quiz Tuesday. Yeah. You didn't see it? Okay. I'll double check, make sure. What if I switch gears and ask you for perimeter of this one?
Okay, so let's just add it up.
We've got 12 here, right?
Yep, 12 here.
20 there.
It'll be 12 on the
There's
other
no 12 here. That one's not. That's not on the edge. We can't put 12 for that. But there's a 20 down here, right?
side. Right.
But now we need to do this curve. How's that curve going to be? Well, it's going to be circumference of the circle, which is pi times
5 times all.
diameter, pi times 12. That's going to be divided by 2 because it's only half.
Right. So it's
3.14 times 12 divided by 2. 18.84. That adds up to 70.84 feet. Is our perimeter. What do you think? Look confused, Cody. Really?
Really?
Nobody else that use calculators?
Oh, you're the only math teacher I had.
Oh.
College, but in high school you could use calculators.
Yeah, they have to show you what. Or
Yeah,
you
but-
can do it instead.
Yeah, I've known a lot of people like that. They look at it, they just know how to do it, or they know what to do. I mean, I'm a big person for writing stuff down myself because it keeps you from making some silly mistakes. But if you know the answer, you know the answer.
My son is so good with numbers. Oh my gosh, you don't get that from me.
So for this one, we're going to start out by finding the area. And I actually gave you a hint. I put these two little dimension things in here. To find the area, we're going to have to find those. But what I'm going to do is this. I'm going to show you this. We're going to do this. We're going to find a whole rectangle here. What's this dimension of this rectangle?
Well, that's 15.
That's a 3 there that I just covered up. So 15 plus 3 is 18 feet, right?
Yeah.
What would this dimension here be?
15?
12 plus 4
Oh,
is 16.
wait. What about the 3?
Well, we'll come back to that. The 4 goes this way, though. 12 and 4 make the 16. We have to subtract. This piece is going to have to come out later.
Oh, wait. So, 15 you added 3.
Yeah. The 15 and the 3 go this way. The 4 goes up and down. That goes with the 12 to make the height.
Well, why does that go with 15? Why does
Or in the,
The 4 and the 12 because we're trying to get this distance. So the 12 and the 4 are both going vertically, up and down.
Okay.
So they add together to make the 16 here.
Okay.
So we're going to start out with the area of that whole thing, which is 18 by 16, otherwise known as 288 square feet. But the actual area is smaller than that. We got pieces that have to come out. Yeah, this piece here is 3 by 4, 12 square feet. So that puts me down to 276 square feet.
But this seems a bit too big.
This piece up here, how's this? How long is this piece? Well, 16 minus 10. That should have been 11 feet. I screwed that up.
Well, let's see.
This is 11.
That side's 12 feet. That side has to be 12 feet as well.
No, if this is 16 total, right?
Oh, yeah.
This is 11. This has to be 5, right?
Yeah, because,
To add up to 16.
yeah.
This dimension here, if this is 18 and this is 6, this has to be 12. Obviously, I didn't draw this to scale.
It's 6 minus 18.
Yep.
Okay. And then do subtract that out.
So now this area here is going to be 12 times 5, but I can't leave it like that. It's a triangle, which means I have to divide by 2, which would be 30 square feet. So minus the 30 is 246 square feet.
And that's your answer?
That's our answer. That's the area after those pieces have been subtracted.
If I got you right, 15 plus 3 is 18.
Yep.
To get that side.
Yep, to get this.
And 4 plus 4 to get that side.
Get that, yep. And that's what we used.
Use times 16 times 18 to get 288 feet squared.
Correct.
Then to get the 12 is 3 times 4.
Yep.
And you subtract that out.
Yep.
And then to figure out the two side lengths there, you subtract each of
Yes.
So 16 minus 11.
You got it.
6 minus 18.
How did you do 246? What?
I had the 288 was the whole big thing, right?
Yeah.
And then from that, I had to subtract the 12 here for this one, because that's 3 by 4.
Yeah.
So I subtracted that. That puts me 276.
Yeah.
And then this one we found to be 5 by 12, right? But it's a triangle, so it's 5 times 12 divided by 2 makes 30. So we subtracted that from the 276, gives us 246.
Okay.
What if I asked you to find the perimeter of that one? Well, we got 6, 12, 3, and 4. Let me write those down. Add up all the sides, right? Plus 15 plus 11 plus, I still need the length of this side right here, don't I? How do I find the length of that side?
12 times 5.
No, it's a triangle, so it'd be 12 squared plus 5 squared equals c squared, right?
Oh, okay.
We have a triangle that looks like this. Here's my right angle, here's 5, here's 12. This would be, excuse me, that would be that hypotenuse, we'll call it C.
So let's see, 12 squared is 145.
Perfect.
So you add those two squared.
Yep.
Then you take the square root of
The C is 13. So we have 13. So what do we have there?
Okay, so it's
40, 51, 64, I believe.
okay, so area is the inside, perimeter is the outside.
Perimeter is the distance around, and area is what's inside of it. Yes.
Okay. And both you're kind of adding up both sides.
Yep. Questions? Good.
Please.
So our next part is the part that most people stumble on. We covered it for a couple days, but we did go through it quickly. Depending on what program you're going into, you may need more or less of it. But we're going to look at volume and surface area. It doesn't have to be, but it is. So let's say we have a radius of 4 units, 4 inches we'll call it, and a height here about 13 inches. Finding the volume, the first step is always to find the area of a base. For this shape, the base is what?
4.
Base is a circle with a radius of 4. So that area will be pi times radius squared, so pi times 4 squared, which comes out to be 50.12 inches squared. That's the area of the base. That's this down here.
Okay. So then it's
You got it. The volume then is the area of that base times that height of 13. I said 50.12. It's 50.24, isn't it? I rounded wrong. Hold on. Sorry about that. It should be 50.24. Yep. Yeah, I made a mistake. It happens. It may happen again someday. Not very likely, but maybe. So we get 653.12 inches of that is your volume.
Where is the practicality that you will actually use this?
If you're working for several companies, we're looking at storage tanks, maybe volume storage tanks. Those are going to be cylindrical. It actually even be slightly more complex than this even, because you'll probably have spherical ends on it, or at least one domed end and one flat end.
Speaking of weird shapes, you actually had it think here.
Hold off, we'll talk about that. You can show me that later. Yeah.
Did you get it?
No, I didn't.
Oh, yeah. That extra credit question is fairly challenging. I'll give you that. So, surface area. Remember, for surface area, we have the area of the base, 653.12. The top is also the same area, so there's the second base, 653.12. And we're going to add those, but what else do we have to have? We have to have the area that wraps around this thing, don't we? That is called the lateral area. And to find the lateral area, we need to know two things. The first of those is the perimeter of the base. Well, since this is a sphere, the base is a circle, so the perimeter of the base is just a circumference. So that'd be pi times diameter, so pi times 8. Otherwise known as 25.12 inches. From that, our lateral area is going to be that perimeter of the base, 25.12 inches, times the height of 13 inches, and that's it, right? Should be 326.56. There we go. And we add that all up. You get 1,632.8. Somebody double check me. That'll be inches squared for surface area. Yeah, 25.12 times 13. That gave us the 326. Then we add the 653, the 653, and the 326.
Obviously, you times 13 plus 1.
What's that?
Wait, so
This, multiplying this, gave us the 326 here, right?
yes, 326.5.
And then we have to add that to the area of our two bases. So 326 has to get added to 653 and another 653. Oops, I wrote down the wrong number there, didn't I? It's not 653. What should go there? The little hamster may have fallen off the wheel. Area of my base is 50.24. I just wrote down the wrong number. So let's try that again. The lateral area is the 326. The area of my base is the 50.24. But there's two of them, top and bottom. So that's going to change just a little bit. That's going to make this 427.04, I believe. Sorry about that. I'm going to pause here so you guys can fix your notes if you need to. Okay. Good call. Let's do a sphere. It's a sphere with a radius of 6 inches. Remember, the volume of a sphere is 4/3 times pi times the radius cubed.
I'm not seeing, I'm not seeing.
Use your imagination. I can't draw. It looks like a sphere, sort of. So the way I would punch this in my calculator, I'd do 4 divided by 3 times pi, so I'm going to use 3.14, times 6 to the power of 3. 904.32.
Wait, okay, so you took the radius, 6,
Yep.
and then
Two.
you plug that into the equation, which is, what exactly?
That's the volume.
Okay, so volume equals
4 divided by 3 times 3.14 times, and then in this case, 6 to the third power.
okay, so is 6 the only thing you're plugging in then?
Yep, the radius is the only number you plug in when you're doing a sphere.
So if that was like 10,
It would just be a 10 here, yep.
okay? So it's always going to be V equals 4
Yes.
divided by 3 times pi
Yep,
times x to the power.
exactly.
So how do you do, like, if you take 6 to the third power, how do you do that on your calculators?
You've got this caret key right here somewhere. Yours is probably over on the left side, about halfway down.
This caret.
Yep,
Oh, so you just do
6 caret 3. Then it equals.
216.
Yeah, 216, and then times pi times 4 divided by 3.
Got it, okay.
Surface area is 4 times pi times the radius squared. So if you punch that in your calculator, you're going to get what?
Okay, so 4 times
Yep,
times 6.
6 squared. So 6 either caret 2 or 6, so you might have an x squared key on your calculator.
So 452.16.
457.16, shouldn't it be? Let me double check. I might be wrong. Oh, you're right, 452. I don't know why I put 457.
Oh,
The little hamster probably should just go back to bed and let me use the calculator for the rest of the day, yeah? Thanks, Cody. So the spheres are probably our easier ones to calculate because you just have to memorize the formulas. You just have to do it. So this is going to be 4 times pi times 3.14 times 6 to the power of 2.
Okay, so then going on that knowledge,
Yep.
what is the radius of the Earth then?
The radius of the Earth is like 2,400 miles.
Oh, cool. So happy you knew that off the top of your head.
I know, I'm a geek. What's your point? It happens. Volume. Tell me how to find it.
Which one is the height?
Good question. Which one's going to be the base? Let's use this as the base down here. So the area of our base,
It should be 15.8.
16. 16 is the other side of the base here. 18 is the height.
Okay, okay.
So that's going to be 240 square inches. So the volume, we'll take the area of the base, which is the 240 square inches, and we multiply it by the height of 18 inches. And since my little hamster has not done well today, let's do 240 times 18. No, that ain't going to do it.
4,321.
Sounds good to me. 4320. That'll be inches cubed for volume.
Now, question.
Yes, sir.
We don't put the inches cubed on the end of that. We're looking at long.
Possibly. You should have the correct units.
As long as we have the correct answer.
Should have the correct units. You might lose half a point or something for having the wrong units. If you put inches squared or don't put anything at all, you might lose half a point.
Okay. Good to know.
Yep. So for our surface area, once again, we still have to include the area of the base here, which is going to be the 240. And there are still two of them, top and bottom. Lateral area. We need to know the perimeter of the base. Well, that's going to be 15 plus 16 plus 15 plus 16, right? Okay, 15, 16, 15, 16. Around that bottom. Otherwise known as 62 inches, correct?
Wait, what?
Perimeter of the base. So we're adding up 15 plus 16 plus 15 plus 16. The distance around the base. So here's our lateral area. I wish I could get rid of this cough today. Of 62 inches, the perimeter base, times our height of 18 inches, which is 1116.
Wait, you said 62 the height, right?
Yep. The perimeter of the base times the height, which is 18. So now we've got that 1116 square inches plus the 240 and the 240. So this is 1596 square inches.
Oh, wait, the 240 was the area? No.
240 was the area of the base from up here. Yep. So 1596 is our total surface area. I'll wait for you. Okay, so next. Pyramid. And let's say our pyramid is a base of 12 inches square, height of 8 inches. Again, I know not drawing the scale. Find volume. I'm coughing right in the microphone too. I'm sure that sounds horrible. Excuse me. For find the volume, what is our first step is going to be to find the area of the base, which will be what? 12 times 12. Or 144 square inches. Then we take the area of the base for the volume. We take the area of the base. Oops. I was thinking 144 times 8, and I mixed them together. 144 inches squared times 8 inches of height divided by 3. Or it's a pyramid or cone, the volume is divided by 3. Just like a triangle, you divide by 2. Pyramid or cone, you divide by 3. That's 384 inches cubed.
Unless we're going into dimension shape.
And we're not.
How do you solve?
Not in this class, we can't. Surface area. Now this time, because there's only one base, we only have the area of one base to add in here. We don't have to put it down twice because there isn't a top one here. For the lateral area, we need to know two things. Once again, we need to know the perimeter of the base. Will just be 12 plus 12 plus 12 plus 12, right? 48 inches. That's the perimeter of the base. But we need to know not the height, but the length of the slant. Because this edge doesn't go straight up. It goes up at a slant.
Wait, we're
Trying to find this edge here. You're going up the edge of the triangle.
but
Basically, it's the height of the triangle. It's just not the height of the pyramid.
so we're using the area of space to find out the surface area, but in order to find out the surface area, we need the slant.
This slant. This right here, from peak down to the middle here, is the slant. And to find that, we use this right triangle. We know this is 8 and this is 6, half of the 12, right? So 6, 8, and then whatever that is. So 6 squared plus 8 squared equals that slant squared. If you figure that out, the slant comes up to be 10 feet, or 10 inches. 6 squared is 36. 8 squared is 64, and together that's 100, square root is 10.
Don't you have the square ten though?
Nope. This is going to be 36 plus 64 equals s squared. That adds up to 100 equals s squared.
Oh,
Square root 10 equals s. It's the square root that you were thinking of. So our lateral area is the perimeter of the base, 48 inches, times that slant height of 10 inches, divided by 2. Why do we divide by 2? Because they're now triangles now instead of rectangles. Good. So this is now going to be, what, 240 inches squared. So 240 inches squared added to that, we get 384 inches squared. Any questions? We got 10 minutes left, so let me squeeze it up. Do you need that yet for a second? You copy it down?
Oh, so if I got you right, final lateral area.
It is the slant height. Oh, sorry. It's the. Come on.
Area.
We need the perimeter of the base
Okay.
times the slant height divided by 2.
Okay.
Or that perimeter of the base is not the area, it's just adding up the 4 sides around the base.
And
That's here.
the slant height.
Use the height and then half of the width of the base to get that right triangle.
Okay, so the height is and half the base,
Uh-huh.
the whole base, or just 12?
Just.
So it's 8 times 12.
Oh, wait.
divided by two.
For. You lost me there now.
The slant height.
Oh, no. The slant height is 8 squared plus half of the 12. So 6 squared would be half the 12.
Oh, wait, so it's,
That's where the 6 came
so
from.
it's 8 squared plus 6 squared equals s squared.
Yep. So you got a squared plus b squared equals c squared. Yep.
So it's like
Pythagorean theorem. It is the Pythagorean theorem, yes.
but if now what if we could talk about the
Not yet.
extra credit?
I won't give you hints on the extra credit anyway.
Not even what to use?
I'll give you a hint. You can make it into a complete half circle. That'd make it easier. Yep.
Wait, so you make it a complete circle?
Well, a complete half circle would make it easier.
Now,
It's not a complete half circle right now because it's wider than it is. The height is not half the width. I know, that one wasn't very nice.
can you give us an easier extra question?
No, actually, I can't. I want to find X and Y here. I will tell you that these shapes are similar. Excuse me. What do we need to do?
Oh, okay, so, let's see, 12 divided by 8, 15 divided by 6.
Okay, the 12 becomes the 8. So we're going to set up that proportion. 12 over 8. 12 to 8. 15 becomes what?
6.
15 becomes
Oh, wait, no, X.
x. Which one's going to go on top?
15.
15 because it comes from the same triangle as the 12. And bottom will be x. So we will cross multiply and divide to get x is...
So 18 times 15.
8 times 15 is 120. Divided by 12 is 10. X is 10.
Wait, what about Y?
Well, what about y? 12 still goes to 8. The y goes on top this time because it's from the same triangle as the 12. What goes on bottom? The 6.
No, the ones that really get me is when it goes up by 1.
Cross multiply and divide. 12 times 6 divided by 8. That should be 9. Right?
Yep.
Oops, over here. Not so bad?
That's not bad.
Okay. Let's say Cody buys a new ship. New boat. He's gonna buy it. He's finally struck it rich like he deserves to, and he's got a yacht. Right? Cody's driving his new yacht. Look pretty good on a yacht, Cody. You have to get one someday. And then share with me, of course. Okay. So on his yacht, Cody takes a trip. He goes 99 miles south. Then he turns and he goes 20 miles west. At this point, how far is he away from where he started? This is the right triangle.
It's 20 squared
There you go.
plus 99 squared.
A squared plus B squared equals C squared.
99
20 squared is 400. 99 squared is 9,802, right? No, 801. 801, okay. C squared. We add those up. 10,201 equals C squared. We square root. That's 101. Equals C. Correct? Square root, you got to do second x squared, and then type in the 10201.
Then you type in
Second x squared, then the 10,201. 10201.
so 101.
Yep, 101. Which always seems strange to people because they go 99 miles south and then 20 miles to the west, and they're still only a couple miles further away than they were when they turn. It's kind of strange that way. Well, it has nothing to do with the curvature of the Earth, though. We're assuming a flat surface, and a small scale, you assume a flat surface on the Earth. 99 miles is not a large enough distance to have a significant curvature of the Earth that you have to consider, really.
Is what I know is that if you're going long distances on a ship and you want to get somewhere, you don't go in a straight line.
You actually make an arc, yeah. Go over the top of the world instead of around the side of it, yeah. Well, there's no homework, no quiz or anything like that for tomorrow. But tomorrow will be your last unit test. Now, things that we did not review because we've just covered them in the last couple of weeks. We're making graphs. Graphs, I mean, you need to be able to make a bar graph. Sometimes called a histogram. You need to make a pie graph or a circle graph. You'll need to be able to go line graph. Remember, the line graph shows the change over time. You'll need to be able to calculate mean, median, and mode. You need to be able to do a standard deviation calculation.
How do you do the standard deviation again?
That's the 6-step process. Find the mean, subtract the mean from each number, square it, add them up, divide by n minus 1, square root.
Okay.
You will need to be able to do that empirical rule. That's the bell curve with all the percents underneath it that we did today. And the last thing is you will be able to have to graph a line. That's non-statistical. That's like if you have y equals 2x minus 3. If you recall that, that's where you started out at -3 right here. Make that a fraction, 2 over 1. So you go up 2 over 1 is your second point, and there's your line. Remember doing those? Okay. Well, that is it for the day.